Okay, so hello everyone. So in this video, again we have a fairly interesting question pertaining to what's say basically orientation of ellipses. So let's take a look. Let f(xy) equal to minus y I vector and plus x j vector and c be the ellipse x squared by 16 plus y squared by 9 equal to 1, oriented in counterclockwise or anti-clockwise direction. Then the value of y phi f vector into dr vector round up to two decimal places is. So with that said, let's take a look at how we should go about solving this particular question. So what we have over here is, so f vector comma x comma y is given as minus y vector plus x j vector, and ellipse x squared by 16 plus y squared by 9 equal to 1. So here if we take integration of f dx, so we have curl f to k vector dA. So this will be further given as integration 1 minus of minus 1 dA. So if a factor equal to mi plus mg cap and curl f equal to n by dx minus m by dy k vector. Okay, so I hope up to this much is clear. So this would further give us to dA. Now simply putting the formula of the area of the ellipse this way: 5, 4, 2, 3. If x squared by a square plus y squared by b square is equal to 1, then area of ellipse is equal to pi a b. Okay, so this particular form has been matched. Here this is a square. Let me just highlight this with a different color so that things become clear to you. Here 16 is a square, 9 is b square, therefore a is 4, b is equal to 3. Okay, and we are only concerned with the positive values here. So this can be further given as 24 pi, which would actually give us 75.36, which is a final answer. So hopefully this question is clear to you, the approach we have taken to solving this and how we have come about with all the calculation part, and particularly this important concept. Okay. Hopefully this is clear to you as well. So with that said, we have come to the end of the video. Make sure you go through the video well and try to solve it yourself to get a better understanding on the approaches and the various integration functions that we have used towards solving this particular question in general. So with that said, I'm signing out. Thank you so much.